The last thing we need to talk about is the negative exponent property, and the negative exponent property says that for any non-zero number a and any integer n, a raised to the negative n is the reciprocal of a to the n. And also the reciprocal of a to the negative n is a to the n. Okay, here's the way I think of this. When a number has a negative exponent, it's not very happy. If you think of someone in your life who's negative all the time, and we can probably all think of someone like that, they're just not happy. They want to be somewhere else, okay? Maybe for some of you it's being in math class. You become negative when you get to math class, you just want to be somewhere else. So right now, this person, this a, is negative, and we can see it's in the numerator. It's over 1. It's somewhere it doesn't want to be. Well, how does a negative person become happy? Well, we got to give them what they want. Okay, we got to change where they are. When we change where they are, they'll become happy. So they're not happy in the numerator. Once they go to the denominator, though, that exponent becomes happy. It becomes positive. So negative people aren't happy where they're at. Negative exponents aren't happy where they're at. The way to make a negative exponent positive, or the way to make it happy, is to switch places. So here, if we look at our two examples, we've got 2 raised to the negative 4. 2 raised to the negative 4 over 1. This isn't happy. It's negative, so we're going to move it from the numerator to the denominator, and now it's 2 raised to the positive 4. We put in the denominator, now it's happy. And then you could just simplify 2 raised to the 4th is 16, so we could say 1 over 16. If we look at our second example, we've got 1 over j to the negative 4. J to the negative 4 is negative. Okay, we've got a negative exponent. That exponent is unhappy. How do we make it happy? How do we make it positive? We just change its spot. So we go from the denominator to the numerator, and now it is happy and positive. So we're going to look at a few examples here. We want to simplify each expression, and as always, we assume that no denominator equals 0. Here I've got n raised to the negative 5th times p to the 4th, r raised to the negative 2nd. If I look, n raised to the negative 5th and r raised to the negative 2nd, both of those are unhappy. Neither one likes where it's at. But if we look at p raised to the 4th power, that has a positive exponent, so that is happy. It's going to stay in the same place. So all I need to do is rewrite this and make everyone happy. To simplify an expression, you don't want negative exponents. We got to make everyone happy. So we know that p raised to the 4th power is going to stay in the same spot because it was positive. But now we got to look. Where do I move everything else in order to make it happy? Well, n raised to the negative 5th wasn't happy in the numerator, so I'm going to move it to the denominator, and now it's going to be n raised to the positive 5th. It moves to the denominator, it becomes positive. My exponent's positive because it moved places. R raised to the negative 2nd wasn't happy in the denominator, so I'm going to move it to the numerator, and there it will become positive because it moved. And then you're done simplifying it. We get p to the 4th r squared over n to the 5th. Always make sure to write your variables in alphabetical order. Looking at part B, we have 5r to the negative 3rd t to the 4th over negative 20 r squared t to the 7th u to the negative 5th. What we're going to do here, I like to think of breaking this into different parts, okay? You kind of break it into parts. We've got constants, we've got r's, we've got t's, we've got u's. Okay, and you do not have to rewrite this, but I'm going to rewrite this one time just to make it easier. Okay, so I'm going to think of this as being the same thing as 5 over negative 20. And then I've also got my r to the negative 3rd over r to the 2nd. Then I've also got my t's, t to the 4th over t to the 7th. And then I've got my u. Now, I just have u to the negative 5th in the denominator. I have nothing in the numerator. If you don't have a term in the numerator that you want for a variable, or in the denominator, you can just always put that variable raised to the 0 power. Because we know any variable raised to the 0 power is just 1, so that's not going to ever change anything. And then, now that I've got this all written out in pieces, I can simplify each individual piece. 5 over negative 20, that's going to simplify to negative 1 over 4. Remember, negatives go in the numerator, so when I simplified this, I divided each by 5. I just moved the negative to the numerator. Then I've got r to the negative 3rd divided by r squared. Remember, when you divide, you subtract exponents. So I've got r to the negative 3 minus 2. Negative 3 minus 2 is negative 5. So I get r raised to the negative 5th. Then I have t to the 4th divided by t to the 7th. When you divide, you subtract exponents. So I get t raised to the 4 minus 7, which would be t raised to the negative 3. And then I have u to the 0 divided by u to the negative 5. 0 minus negative 5. Remember, when you subtract a negative, it's like adding a positive. So 0 minus negative 5 is the same thing as 0 plus 5. So we get u raised to the 5th power. Last thing I want to do is simplify this so I have no negative exponents. And I'm going to get negative 1. R to the 5th wasn't happy in the numerator, so I've got negative 1 over 4. R raised to the 5th's got to go in the denominator because it's not happy in the numerator. T to the 3rd has to go in the denominator because it's not happy in the numerator. U to the 5th was positive, so it was happy to be in the numerator. So I get negative 1 u to the 5th over 4 r to the 5th t cubed. And there's my answer. These problems are much simpler if you just think of them piece by piece. I am not going to expect you to always write out each individual piece like this, but just think about that we're breaking apart our fraction and thinking of the constants, then the r's, and the t's, then the u's. And remember, if you don't have a u in the numerator or you don't have a u in the denominator, just put a u to the 0 because we know anything raised to the 0 power is 1. Last one I want to look at, we've got 2a squared b to the 3rd c to the negative 5th over 10 a to the negative 3rd b to the negative 1st c to the negative 4th. I'm going to think of this piece by piece, but instead of writing it out like I did last time, I'm just going to do it all at once. 2 over 10, that's going to become 1/5. I've got a squared over a to the negative 3rd. 2 minus negative 3 gives me 5, so I've got a raised to the positive 5. b to the 3rd over b to the negative 1st. 3 minus negative 1. Again, when you divide, you subtract exponents, so it's 3 minus negative 1. Same thing as 3 plus 1, so I get positive 4. And then I have c raised to the negative 5th divided by c raised to the negative 4th. Negative 5 minus negative 4 is negative 5 plus 4, so I get negative 1. And then to rewrite this, I don't want any negative exponents. I've got 1 over 5. A to the 5th was happy, so I can leave them in the numerator. B to the 4th was positive, so I can leave it in the numerator. C to the negative 1st, it's negative, so it's unhappy where it's at, so I have to put c to the 1st in the denominator. And there's your answer. I've simplified this fraction. I've only got one of each variable, no negative exponents, so I'm done simplifying. And that's all there is for this lesson. Let me know if you have any questions.